Hello everyone. So now in today's tutorial we are going to discuss some very important questions based on spherical mirrors. So let us all start. The question number 1 says that name the spherical mirror which has a virtual principal focus and which has a real principal focus. So let us all try and understand that we all know spherical mirrors, they are of two types. This is a concave mirror, okay, and this one is a convex mirror. So if this is a concave mirror and this one is a convex mirror, so if a incident ray of light is parallel to the principal axis, it is a converging mirror, so it passes through the focus actually. But in case of a convex mirror, since it is a diverging mirror, so if the incident ray of light is parallel to the principal axis, after reflection it will bend away from the principal axis and it appears to diverge from a point called the principal focus. So we all can see that clearly, that virtual principal focus is in case of a convex mirror because this focus is behind the mirror, and real principal focus is in case of a concave mirror because that focus is in front of the mirror and the reflected ray of light actually passes through that. Okay, now moving on to question number 2, that out of convex mirror and a concave mirror, whose focus is situated behind the mirror. So we have the diagram also right in front of us. So we can see that in case of a convex mirror, the focus is behind the mirror because reflecting surface is actually the main part of the mirror. This is the polished surface. So it is behind the mirror in case of a convex mirror. Okay, so this is the answer to B part. Now find the focal length of a concave mirror whose radius of curvature is 32 centimeter. So we all know that radius is double the focal length, and if we have to find out the focal length now, so that will be half of the radius of curvature. And since the mirror is concave and the radius or the center is in front, that is to the left side of the pole of the mirror, so that will be minus 32 centimeter upon 2. Okay, radius of curvature is minus 32 if we follow the sign conventions. So that will be minus 32 upon 2 is equal to f, and the focal length will come out to be minus 16 centimeter. And what does this minus tell us? That it is to the left of the origin. Okay, that is the distance from the pole is to the left of the pole, and pole is also called as the origin of the mirror. Right, now moving to question number 4th, that if the focal length of a convex mirror is 25 centimeter, what is its radius? So let us quickly understand. This is a convex mirror. Okay, its reflecting surface is curved outward. This is the focus, this is the center, and this is the pole. So from the pole we are going to the right hand side. It means the focal length will be positive. So if focal length is 25 centimeter, positive sign we want to put it, हम लगा सकते हैं. We do not want to put it, we can ignore it also. Now what is the radius of curvature? So we all know radius is double the focal length, so it will be 2 into 25, and the final answer comes out to be 50 centimeter, and it is going to be positive. Right, so that is how we solve the numerical problems or the questions related to the spherical mirrors. We should have an idea that is focus in front of the mirror or behind the mirror. For a concave mirror it is in front, and for a convex mirror it is behind the mirror. Now let us start with question number 5. Okay, now question number 5 is in the form of fill-ups. So question number 5 goes like, fill in the following blanks with suitable words. So we have to put up a word over here which suits the best. So parallel rays of light are reflected by a concave mirror to a point called the. So if this is the concave mirror, its reflecting surface is curved inward. So if these are the parallel rays of light, okay, so after reflection they all passes through a point, and what do we call this point? Yes, we call this point as focus. Okay, second one, B part, the focal length of a concave mirror is the distance. So beta, if this is the focus, the origin or the center point of the reflecting surface of the mirror is called the pole. So it is the distance from the pole to the focus. Okay, every distance is measured on the x-axis from the pole. Remember that. So it is the distance from the pole to the focus of the mirror. Okay, then C part, a concave mirror dash rays of light, whereas convex mirror dash rays of light. So it's very easy. A concave mirror converges. Now what do we mean by converges? That if this is a concave mirror, so the incident ray that is parallel to the principal axis after reflection from the mirror will pass or will bend towards the principal axis. It will be reflected towards the principal axis. Okay, and what is the second part? Whereas a convex mirror diverges. Diverges means now a convex mirror, it will not after reflection. Okay, if this is the incident ray of light, so now it will move away from the principal axis. So such a type of a mirror is the convex mirror. Now D part, for a convex mirror, parallel rays of light appear to diverge from a point called, now we all can see that this is a convex mirror, so it is diverging, but from which point will it appear to diverge? It is called as the principal focus. And remember that this principal focus is a virtual focus, because it is not actually diverging, but it appears to diverge. So I hope that you have understood that how do we solve the questions related to mirrors. We should have an idea that where the center and the focus of that mirror is, and is that mirror converging or diverging. We can solve any type of question that is given to us. Thank you for watching this tutorial. Thank you everybody.